Welcome. This is Mr. Lewis.
Mm-hmm.
If you haven't caught his name yet, today's the day to do it. And I'm
Yep.
Mr. Miller.
All right.
All right, video number 95. You notice a little bit more hair on Mr. Lewis now.
It's grown back.
It's got
Yeah.
For a while, this part and this part were almost the same.
That's true.
All right, hypothesis testing using means for means. So this is start of one of our last topics. So we'll be doing means for about 2 weeks or so,
Mm-hmm.
a little over 2 weeks. Some new things, but a lot of familiar concepts.
Yes.
Okay.
Yep. All right. So we're back. Just a review of the central limit theorem.
Mm-hmm.
Okay. Understanding that if we have a random sample that's drawn from a population with mean mu and standard deviation sigma, that our sample mean, okay, is has a sampling distribution with the same mean, okay, but our standard deviation is now our sigma divided by square root of n.
Right, so we talked about this, and we're going to draw a diagram,
Yes.
but we focus a lot on proportions so far.
Yes.
And we know the formula for standard deviation for proportions and things like that. So now we're switching back to means. So when we take a sample, on average, it's going to equal the true mean. So this is going to equal mu. So mu represents the mean of the population. So on average, it's going to be distributed around the true average.
Mm-hmm.
Like if we're sampling NBA players for number of rebounds, if we take a sample, the sample average is going to be distributed around the true value.
Yeah.
Kind of like proportions was the same thing. It'll center around the true proportion of the population.
Mm-hmm.
Same thing for means. Now, there's a formula for the standard deviation. So the standard deviation of x bar is sigma, that's the standard deviation of the population, divided by square root of n. And on a previous quiz, it's like a ghost or a mouse or something over there.
Yeah.
Let's do this quick. We either have ghosts or mice here, so
Yes.
one of the two.
Very
Equally annoying. It could be both. All right, so sigma over square root of n. All right, so we had some problems on previous quizzes like this, and we're back to focusing on means now. So this is a distribution of it.
Mm-hmm.
All right. So here's our first sample. We're going to walk through one example of a hypothesis test.
Mm-hmm.
And we'll be talking about, there's some new stuff in here, and we'll be going through it. And just realize we're going to practice a lot more in class.
Right. All right. So here we have 14 brands of vanilla yogurt, and the following numbers are calories per serving. Is there evidence that the average number of calories is not 120 per serving?
Okay, so
Okay.
120 is assumed value.
Right. So what characteristic population are we interested in? That would be the
Average calories per serving.
average.
Yeah.
Right.
Okay.
Okay.
And here's, usually we won't tell you this, but here's some things we're going to need to know to do the hypothesis test. So we'll just talk about these now. There are 14 data items, so n is the number of data items. X bar is the sample average.
Which
Okay.
we kind of have to roll through.
You want to pause real quick, Mr. Lewis?
We could.
We're going to pause real quick.
Hang on. Okay, and we're back.
Yeah, so now we're back with the mean. So n is 14.
Uh-huh. So, n was 14.
X bar, I get 157.9, which does seem quite far from 120.
Mm-hmm.
And S, that's the standard deviation of the sample.
Yes.
Okay, so not the population, but the sample. That's 44.8. Okay, so those are some things we're going to need. So now we'll talk through the test.
Right. So, HO, okay, so our null hypothesis, well, that would be that the average is 120.
So mu equals 120. Okay, so we're going to assume it's 120 for the population.
Mm-hmm.
And our alternative hypothesis is that it is not equal to.
Right.
So this is a two-tailed test.
Yes, it is.
Okay. All right.
Okay.
Now, here we have a choice of statistics.
Yes.
We got Z and we got T.
Right. So basically the idea is use Z when you have a very, very large group and use T when you have a very small sample.
Right.
Usually, 30 is kind of the cutoff. All right. So here we only had 14. So we are going to go with the T statistic.
Now, the big difference is, what's the difference? Both have X bar minus mu on top.
Mm-hmm.
The difference is in the bottom. On Z, Sigma is the standard deviation of the population.
Right.
And actually, we got no idea for the whole population of yogurt brands what the standard deviation is.
No.
And usually you don't. So what we're going to use instead is S. And actually, this makes a big difference. These have slightly different distributions. So this is one thing new about means. Often we're going to use the T statistic. And we'll introduce a little bit about that. It's not going to be bad.
No.
It's almost the same thing. We just use a different distribution than the standard normal.
Right.
Okay, so we're going to calculate the value. So we're going to go ahead.
Oh.
And is that on, I think it's on the next page, right?
I think it is.
All right.
So compute the test statistic for the data. So
okay, so T instead of Z. So T equals
X bar,
which is 157.9,
minus 120,
the assumed value, divided by S,
44 point what?
44.8 over square root of N, which is 14. And maybe we want to put parentheses around the bottom. What do you think? I think we have to be really careful about how we do this. Okay, so here we go. So 157.9 minus 120. Okay, I don't think you need a calculator for that. 37.9 in the numerator. And let's figure out the denominator. 44.8 divided by square root of 14. Denominator is 11.97.
And what do we got?
It's 37.9.
Probably somewhere around 3.
Divided by 11.97. It is 3.16. Now, it looks a whole lot like a normal curve, but it's slightly different. In fact, they used to use a normal curve for this, and someone who actually worked for a beer company, Guinness Beer, his name is Gossett, found out that he kept getting wrong answers and wrong approximations. And his hypothesis tests weren't quite working out right. And it's because when you use the sample standard deviation, it's slightly different than if we'd use the population distribution.
Right.
So even though it looks like a normal curve, it's actually a little bit fatter in the tails and a little bit shorter. And we'll see some comparisons in a minute. But it was different enough that it was causing problems, and someone realized it's not a standard normal. It's actually this T distribution.
All right.
Now, could you write this on the side? T distributions, you don't have to enter the mean and standard deviation. You have degrees of freedom.
You have degrees of freedom.
Yeah. So,
DF.
So the degrees of freedom, for this case, is n minus 1. The number of things sampled, items in the sample, minus 1. So there's a T distribution for 1 degree of freedom. There's T distribution for 2 degrees of freedom, etc. So here, since we sampled 14, this is the T curve for 13 degrees of freedom.
Yes.
Okay, so they all have mean 0, kind of like the standard normal curve, but the standard deviation is a little bit different. And like I said, the tails are actually a little bit fatter. All right, so we want to compute the probability that T is greater than 3.116 or less than. So this is the same thing we did with two-tailed tests in the past, but we're just going to use the T distribution.
Right. So.
And like I said, here's a drawing of the T.
Should be around here. Should be about here.
So it says calculate the p-value. That's what we're doing here. So,
right.
So we're going to use TCDF.
Okay.
So much like normal CDF, but TCDF.
CDF.
Now we're going to use one tail and then multiply it by 2. So let's use the left tail. So the lower limit would be like negative 100,000.
All right. 100,000.
The upper limit is going to be negative 3.16 because I'm doing the left tail. And then it asks degrees of freedom, which is 13, n minus 1. It doesn't need the mean or standard deviation, just the degrees of freedom. And I get that that one tail is 0.0037. So when we times it by 2, we get 0.007. So the p-value, so a lot of concepts the same. We calculate a statistic, we see if it's unusual or not. So if the null hypothesis is true, there is a 0.7% chance of observing the value we observed.
Yeah.
We're going to reject.
Right.
Okay.
Yes. Yes, we are. We're going to do the big reject.
All right, now it's the writing part. The calculator man is done. Okay, we decide to reject the null hypothesis
Okay, so
that the average calorie per serving was 120. That's because our p-value was low. So the difference can't be due to just chance or random sampling. It's a more significant difference.
all right, so we're going to reject the null in favor of the alternative and conclude that the true mean
Is different.
right is different
It looks like it was more, but our test was whatever.
from
It was a two-tail.
120 calories.
Okay,
Done.
so many familiar things, patterns. One difference is using a t-distribution.
Right.
Okay, that's not going to be so bad.
No, I don't think so.
All right, so just to show a little bit, here's a colored graphs. The red graph is a t-distribution with 1 degree of freedom. The blue one is 30. As the degrees of freedom increase and the sample size gets large, it really becomes almost the same as the z-curve, the normal
Yes.
curve. That's why Mr. Lewis was saying for a large sample that you can almost just use the z table because they're almost the same. But if it's a small sample, notice the red is a lot shorter and it's fatter tails. That's what really kind of was messing up the data before the guy invented the t-distribution. So the red one is a very small sample. The green sample size 5, we see already is kind of like approaching a normal curve. Its tails are still, the green, a little bit fat. And the blue one's 30 degrees of freedom getting very much close to a standard normal curve. So you kind of have to understand the differences between a T curve and a C curve.
Right.
Fatter tails in the T curve.
Yes.
But as the degrees of freedom increase and the sample size increase, approaches a standard normal. And ideally, an infinite number of degrees of freedom, it is a standard normal.
Right.
Okay.
Yes.
All right. That's an overview.
Okay. So, your guys' turn. So, a researcher tests whether the mean cholesterol level among those who eat frozen pizza exceeds the value considered to indicate a health risk. So she gets a p-value, of 0.07. So we want you to explain this in context, what the 7% represents.
Yeah, so you don't have to do a hypothesis test yet.
Nope.
But this is about making sure you understand what a p-value means.
Yeah.
So this is kind of old news. All right, super.